have with us today Ed Abufadel. Ed is one of our new board members, and he's taken on a new position for the chapters as he's our research information volunteer. So Ed is being trained by our scientists and people at the national level to communicate to parents like you what's going on in the research world. And he's going to talk specifically about artificial pancreas, but also a little bit more broadly of what's going on, because it all really does play in together. Ed is the chair of the math department at Grand Valley State University, and he's also a dad of a young man living with type 1 diabetes. So welcome, thank you for being here, and hope you'll learn something really good today.
Thank you, Kathy, and thank you for having me today. I want to tell you, sort of giving an outline of how the next hour is going to go. I'm going to be giving a 20-minute presentation, tell you a little bit about JDRF, and then give you some details about 3 different areas of developments in research. One is the Artificial Pancreas Project, which is what was advertised as far as what we're going to talk about. I'll also tell you a bit about what's called smart insulin, and about anti-CD3 therapy is something that current research is being done also. So I'll be speaking for about 20 minutes, and then we'll have plenty of time for questions. So if you have questions, write them down, and we'll save them for after the presentation. So to start off, this is my son Zachary, our son Zachary. It's my wife Kathy over here. And he is 11-year-old now. He's in 6th grade. He was diagnosed a couple days before Thanksgiving in 2007. He plays hockey for the Grand Rapids Association Hockey Association, Graha. And this is not a member of our family here, but somebody that this is sort of a pre-diabetes picture of us at some summer fair or something like that. Zach is doing well with his diabetes. He wears a pump. His last A1C was 6.9, and he's active mostly with hockey. He was playing some soccer also, and he does well in school. And as a dad and as a math professor, I've been learning more and more about diabetes and trying to understand the research that is going on. Now, what is the Juvenile Diabetes Research Foundation, or JDRF? You saw the table out there, and you've probably heard about JDRF, but we are the largest charitable funder and advocate for type 1 diabetes research. And our mission is to find a cure for diabetes and its complications through the support of research, because about 3 million Americans have type 1 diabetes, 30,000 new diagnoses each year. Half the new diagnoses are children, half are adults. What does JDRF do with the money it raises? So last year, in 2010, more than $107 million from JDRF went to diabetes research, and it's been over $1.5 billion since 1970. What we focus on is this image kind of shows you the pipeline that begins with basic research and ends with products that can be used by people for, in this case, for type 1 diabetes. And the 2 places that are circled are the main places where JDRF focuses its money. So one place is right at the beginning. So this is where university faculty, other researchers apply to JDRF for funding for real basic research, trying to understand things about how beta cells work, how beta cells can be regenerated, how high blood sugars affect the body, all sorts of different things that end up being published in papers and journals that these days with the internet you can find a lot of these papers online. But they're very technical. Now the National Institutes of Health, in here they will also fund this, and they will fund what's called discovery research. And it's very easy between exploratory and discovery research for things to stop. And you get papers published, and that's the end of it. Over here is where industry is. This is where, what are companies trying to do? Well, in the end, they're trying to make money. So they need a product. They need to understand to what extent, if they're working on something, they're going to make some money. We're trying to make the connection here between two, to fill in this huge gap here in what's called translational research, from what's published in research journals to what can actually be a product that can be used. And by a product, I mean a drug, I mean something like the pump, something like that, that actually companies are going to make and make available to people who have type 1 diabetes. So a lot of the money goes into what's called translational research. What has JDRF funding made possible in the past? So this has helped make possible. I can't say JDRF, because JDRF, we have these things, but JDRF money went to research that ended up with these products. So for instance, a couple decades ago, the synthesis of glucagon for the glucagon pens that you have in your kits. That was something that JDRF helped support the development of. The improvement of the success of pancreas transplants. The development of continuous glucose monitors that some of type 1 diabetics have now, and new knowledge of how complications develop. By the way, this is from our team walk shirt from this past year. This is Zachary University. Diabetes, see you later. In looking at our strategies to fund research, this image kind of gives you a sense of sort of the big picture of what happens with type 1 diabetes being developed. So this is time here. This is showing what's happening over time. And this is the beta cell mass in the pancreas. And we know that here at the beginning, someone who does not have type 1 diabetes yet has all the beta cells that he or she needs. But perhaps for genetic reasons and for environmental reasons, there's a risk of becoming a type 1 diabetic. So over time, what you see here is that the beta cell mass begins to decline because of environmental triggers, the development of autoimmunity that attacks the beta cells. And you reach a point here where your glucose tolerance is impaired, your H1C is starting to go up, and there's a point down here where you are a type 1 diabetic. So some of the research, the purpose of the research is to either take someone who is a type 1 diabetic and ultimately bring them back up the slide, if you will, or to prevent type 1 diabetes from occurring, so at some point right here to make this line go this way again. So some of the different research areas are for this purpose. Another thing is if you are type 1 diabetic, to say, well, what can we do as far as managing blood glucose? And that's something when we talk about the artificial pancreas, it's really important. So what are the priority areas for JDRF? Well, there's two main areas. One is cure therapies. So in terms, for instance, of immune therapies, to stop the attack of the body on the beta cells. So the type of research, and I'll show you an example of this a little bit later, is antigen-specific immunotherapy. There's also beta cell therapy, where we try to restore the beta cells. And there's research being done in regeneration. About 2/3 of the money that JDRF commits to research goes to cure therapies. Then there's treatment therapies, glucose control. The key phrase there is to maintain tight control. So we're talking about the development of closed loop systems like the artificial pancreas. And this picture here kind of shows you, this is like a pancreas and there's all sorts of mathematical symbols coming in and off it goes. The development of new types of insulin. And then complication therapies to prevent, stop, and reduce complications. So these are different areas of research with that. And about 1/3 of the research money that JDRF gives for research goes to treatment therapies. So one area I mentioned before was the development of continuous glucose monitors. This slide shows you, this is from an article in the New England Journal of Medicine from 2008. And it shows a result of having different type 1 diabetics use a continuous glucose monitor and what the A1C change is. So what blue here is if they use the monitor at least 6 days per week, so maybe they had it on all the time, and then this is where it was used less than 6 days a week, but it was in use. And you can see for different age groups, in each group, the A1C dropped. In this case, it dropped by about 0.5 for age 25 and up, in this case 0.3. In age 8 to 14, there was a drop of 0.71. On average in the use of continuous glucose monitors. So, and as I said, this is important to JDRF as far as funding glucose control research. Even people who use glucose control monitors, on average, only 59% of the day is spent in control, which would be in this yellow region here. 36% of the day is spent high, 5% of the day is spent low. So the question becomes, can we make control simpler, safer, and automated? And that's where the artificial pancreas project comes in. So what the artificial pancreas project isn't, it isn't an object like this that is going to be transplanted into the body of a type 1 diabetic patient. Rather, It's a combination of three things: an insulin pump, a continuous glucose sensor, and then software, a control software, an algorithm that works with the information from here and from here to maximize the control for a type 1 diabetic patient. And this is kind of the order in which things have been developed. So at the beginning, the first development of it in terms of the research was just to have a situation where if you have very low glucose, we turn the insulin off. Makes sense. If you have a low, no insulin. So what would happen first is there would be some sort of alarm. If the user doesn't respond to the alarm because the user is sleeping or something or not paying attention, then automatically we just turn the insulin off until the glucose number, until it rose above 70, say. Next is the hypoglycemia minimizer. So this is for highs. No, lows. Hypos are lows. So this is a case where now you're not low yet, but your blood sugar is declining. And because of other information in the pump, such as how many carbs you've had, when you've entered the insulin in the pump and so on, the software which is developed predicts that you're going to have a low. And you get an alarm that says, okay, it looks like you're going to have a low, do something about your insulin. And again, if there's no response from the user, it will turn off the insulin itself to prevent the low from occurring. Step 3, and this is where we're at right now as far as developing the research for this, is to both take a look at lows and highs. So for step 3, it's the same as 2, but it adds an additional feature of allowing insulin dosing above the high threshold. So maybe you're over 200 or 240, and it automatically gives you some insulin. Looking ahead into the future, as the research develops, next will be some way to combine the basal and the bolus. So you have a fully closed loop system with mealtime manual assisted bolusing. So you still have to enter how many carbs you have and so on, but there'd be more where the software would be figuring out what's going on and be automating how much, not only just the bolus, but also the basal. And then in the future, fully automated insulin with closed loop, and a fully automated insulin and anti-insulin with closed loop. So it becomes more and more acting like the way your pancreas actually acts. One thing that, as they do the research for this, is one of the initial focus is on what happens overnight. Because the reason why you focus on overnight is you don't have, your user isn't eating, there isn't a lot of extra things going on with exercise. If we can get everything to work from 10 p.m. to 7 a.m., that's 1/3 of your life, and that's a step in the right direction. This is research that is being developed, where there's different clinical trials being done on this. One thing, because this is durable medical equipment, there's certain FDA rules for when things will be eventually approved, and that's going to take some time before that's the case. I'm going to learn more about that in a few weeks with a conference call. So I said this is kind of where we're at right now as far as the development of the artificial pancreas. And so again, this is time over here. This is your blood sugar. Here's a low of 50, here's 70, here's 180, and some of the things I just talked about. That in this case, there's an alarm where there's an impending low, and if there's no response, the alarm plus the insulin reduction. So that maybe you do go a little bit low, but we're going to try to minimize the time that you are low. Here's another example. Again, there's an alarm. It looks like you're going high. No response. So the alarm plus automatic insulin gives you extra insulin. So instead of going up here like this, it balances out, and hopefully we can get you below the red zone there also. Okay. A lot of this is developing the right algorithms, the right software to do this. So that involves lots of different things. I know that they do some research where they actually take dogs and they make them type 1 diabetics, and then they try different basal and bolus readings on them, and in order to see what works, what kind of reaction we're going to get in different situations. Clearly, we don't want to do that with human beings, right? But eventually, you get to a certain trials where you have patients who are type 1 diabetics, and then they volunteer to try the artificial pancreas. So this slide kind of shows you what the ultimate goal is here's, when you have someone who's newly diagnosed or after their honeymoon period is over, and they have highs and lows, and we'd like them to stay in this green target here. So the artificial pancreas is a way to kind of work our way in time toward better control. In this area, it shows some of the other things that are being developed. So ultra-rapid insulin. So insulin that will react faster to lower your blood sugar, improves cannulas, microneedles, micropumps, all sorts of different things that different researchers are working on. And the hope is over a long period of time that we'll have a nice narrow band there as far as the blood sugar for a patient with type 1 diabetes. Now, I want to tell you a bit about another area that JDRF has helped fund. It's called Smart Insulin. The company's called Smart Cells. What is going on in this picture? Well, here's a key to this. So in here, this is a combination, these brown-orange things are a combination of insulin and a plastic, a polymer, that are joined together. And these little gray things, these hexagons, are glucose. And the idea is that this is in your blood, is that this is injected into your blood, these polymer, this smart insulin. And what happens is that when the smart insulin becomes in contact with glucose, the insulin is let go from the polymer insulin here, and it ends up, these things get attached together. This is the insulin with the glucose, which is what we need. We need the insulin to work with the glucose. The plastic itself is biodegradable. It's something that then gets flushed out of the body. So basically you have a reservoir of insulin in your blood that's being held in your blood by the polymer, and then it's let go when the glucose is detected in the system. If there's not a lot of glucose in the system, then it's stable and it doesn't release insulin into your body, so you don't have a low. So this was something that the patent was filed in 2003, and just recently this company, Smart Insulin, so from 2008 to 2010, JDRF provided a total of $1.5 million in funding for early stage development. They have proof of concept preclinical trials that are partially funded by JDRF. Just in December, Smart Cells agreed to be acquired by Merck, and currently it's in preclinical but non-human testing. So this will be a way also for glucose control, where someone could get, say, a weekly injection of the smart insulin, and then that smart insulin would react to the glucose in the body. I like this cartoon. And to demonstrate the immune system's devastating attack on the body's insulin-producing beta cells, we will now recreate this encounter with the help of Milton Pitts and Bruno the Mangler. So Milton here is the beta cells, and there's Bruno there with the antibodies. We know that type 1 diabetes involves antibodies attacking the beta cells and destroying the beta cells. And in immune therapy research, the idea is to arrest the autoimmune process, to go from prediabetes, to stop going from prediabetes to type 1 diabetes. Because if the beta cells of a type 1 diabetes patient are regenerated, and there's a way not to have them destroyed again, they'll stay. They will stay in the body, because the body will remember. The body will remember, oh, I know what it means to have beta cells. So there's two pieces to this. One piece is regenerating beta cells. Another piece is stopping the attack of the antibodies. Now here's the antibody part of this. In your body, there are two types of T cells. One is called T effector cells, and they're kind of this scary red thing here because they're the ones that are doing the attacking. And then there's T regulatory cells that are this pleasant blue, because they're the ones that regulate, that tell the T effector cells, okay, slow down, don't go after this, or go after this, don't go after this. So cancer cells, pathogens, toxins, other things in the body. Oh my goodness, see, that sounds like they're attacking right now. So what happens?
They can't have more than 100.
No. What happens when you develop type 1 diabetes is that these effector cells go after the beta cells. And something happens with the regulatory cells that they don't regulate properly. So you see healthy cells in tissues, such as the beta cells. So JDRF has been funding research in what's called an anti-CD3 drug. And they have these names here that I just can't pronounce. I'm sorry. And what's CD3? CD3 is a molecule that's on the tips of these effector cells. And the purpose, they kind of detect, okay, that's a toxin, I'm going to go after this. What the anti-CD3 drug is doing is going, okay, try to slow down that sense of this is a toxin, this is bad, this is something else. In other words, to take those effector cells and lessen their strength. What also the drug does is it tries to boost the regulatory cells, that more cells are created. And the idea would be then that to put your body back in balance so that these cells would regulate these cells properly by making the blue cells stronger and the red cells weaker. In early trials, it helps generate T regulation cells and alters T effector cells' perceptions of antigens, such as beta cells. So this kind of shows another picture of what's going on here. This is from Tolerex, one of the companies that is working on this research. So what this medicine is going to do, it downregulates what are called T effector cells, and it upregulates the T regulatory cells to prevent future attack, autoimmune attack on the beta cells. Now, in itself, this is not a cure for type 1 diabetes because this stops the attack, but the person still doesn't have beta cells. So there's a whole nother line of research that involves regenerating beta cells. And as I said a few minutes ago, if you regenerate the beta cells, your body will go, okay, I know what's going on here. I know what the beta cells are for. We'll start making insulin again. So the way a possible cure for type 1 diabetes looks these days involves these two therapies together. It involves regenerating beta cells and then getting these effector cells under control. Here's an example from a phase 2 trial of using the anti-CD3 drug. So the way to understand this chart is along the bottom here, this is where you have someone who has new onset type 1 diabetes, so recently diagnosed. And this says day 0, month 6, month 12, month 18, month 24, month 36, month 48. So this is 4 years after diagnosis. With the blue dots, that's the placebo. That's where you're not using this medicine that they're trying. And this shows how much insulin is being used on average in a given day. And you see what's happening. This is the honeymoon period here, so there's less insulin needs to be used. And then as we go along in time, there's more insulin being used. With the anti-CD3 drug, as we go along in time, you can see how for a longer period of time, the amount of insulin usage is down here, and it starts to get a little larger afterwards. But it definitely, if nothing else, it slows. It maintains the honeymoon period for longer, and it slows the need for a large amount of insulin over time. So this is a positive result to see this. Some of the results are positive, some not so much so. So phase 3 trials, that's the trial that happened before then there's a serious attempt to actually bring this to market. There was a recent phase 3 trial by Lilly and Macrogenics that was very disappointing. And in fact, Lilly said, well, we're not going to pursue this any further because of how that trial was. However, for the other company, they have other phase 3 trials on the way, and we're expecting more results coming this year. So we have a situation like this where, in this case, the glass is a bit empty, but there is some positive results here and some hopeful results coming along in the next few months. So to kind of summarize things, our research goals for JDRF one is to restore and maintain insulin independence. In other words, to work our way back up that chart I showed you earlier, back up the slide. Prevent and arrest progressions of complications. I haven't talked really about complications therapies, but to prevent any complications over long term from type 1 diabetes, and to prevent onset if possible. And you know, I was talking about the type 3 trial, the phase 3 trial, is what we understand now is there's no magic solutions to this. Finding treatments is expensive, and it's a long process with starts and stops. But progress is being made in understanding the disease and in finding ways to control glucose and finding directions toward a cure. Whoops. So in conclusion, JDRF is a leader in setting the agenda for diabetes research worldwide. We're the largest charitable funder of and advocate for type 1 diabetes research. And most of the money goes to research. There is not a large amount of overhead with JDRF. The mission is to find a cure for diabetes and its complications through the support of research. Thank you. So, the floor is open for questions. Yes?
Which one would be better, the smart insulin or the artificial pancreas?
Which one would be better?
Yeah, well, neither one is really, like, taking away diabetes, I guess. So wouldn't it, I don't know, I personally would just want to take a shot once a week.
Okay.
I wouldn't want something attached to me that may malfunction, and then you're back at square one.
You're right that that's not a cure to take away diabetes. And I think it would depend, well, it depends on ultimately what works, for one thing. I mean, they're still doing the tests with the smart insulin, they're still doing the tests on artificial pancreas. If we end up with having both available to market, then people have a choice of what they'd be more comfortable with. Some people might feel like, you know, having that shot with a little bit of that polymer in my blood, I don't know if I like that. That sounds a little weird to me. I'd be much happier with everything out on the surface where I can see it.
I personally don't want to pump ever, so I don't know if I would feel comfortable having an artificial pump attached to me. You know, like if I didn't like it.
Yeah. Yeah, it's the same pump, right? Or it's a pump with different software, and then you have the continuous glucose monitor attached. So it wouldn't be any different than having a pump now.
Do you have a preference which one you would like, if you had to pick one for yourself?
Oh boy, I don't know.
You know more about both.
Yeah. I'd say right now, because of my personality, I think I'd prefer the artificial pancreas, because if something didn't seem right, you could just unattach the whole thing, right? And it's like, okay, we can go back to shots, we go back to something, something that was working before. With the smart insulin, it seems like, okay, it sounds like it needs to take a few days to get out of your system. That sounds a little different to me. But I don't want to downplay that research, because there's probably more going on I don't know about with that. Yeah. Oh, yes.
With the smart insulin, how is the polymer cleared? Is it cleared by the kidneys? Is it, by the liver? Or do they have all that details?
I don't know. What I do know, let me look at my.
I wonder is, people that are renally impaired,
right?
It's cleared by the kidneys.
Yeah, all I know is it's biodegradable. But you're right. That's a good question, because it could be cleared by either the kidneys or the liver. I don't have that information. So, yeah. Yes.
What is the time frame on these actually coming to market and us being able to use them? And on both of them?
Right.
Do you have a time frame?
I don't. I mean, I know that in terms of money, it costs like $1 billion to go from start to finish. And in terms of time, if you look at some of the other things that have been developed, like the continuous glucose monitors and even the pump and stuff, that's at least 10 years. So for both of those, the two things I talked about, they are in trials right now, either phase 2 or phase 3. Do you have more? Yeah.
Can I add a little
Yeah,
bit to that?
yeah.
The JDRF last year began a partnership with Johnson & Johnson to develop an artificial pancreas. They said they would have this first generation that Ed was talking about, the hypo minimizer, the hyper minimizer.
The type 3, right.
The type 3.
In how many years?
3 years.
3 years.
So they are working with the FDA along the steps in developing this, so that when they do bring it to market, they are hoping for a rapid approval of this. So what we're being told is 2 to 3 years, we should have something available to go to the FDA for approval. And it will just be this, what Ed was talking about, to shut down and give alarms. We'll still have to bolus, but it's the first step in automating this entire process.
Yeah. In terms of the hardware, we have pumps, we have continuous glucose monitors. The continuous glucose monitors are getting better from month to month with that, and they're getting smaller. And it's, so really it's a matter of getting the algorithm to work so that there's a lot of if-thens. If you have so much blood sugar and you have so much insulin and you've eaten this much food and you're going down or you're going up and you have this previous history of whatever, then do this, right? So that's what I think at this point what they're really trying to sort out is sort of all those if-thens that somehow your body, if you don't have type 1 diabetes, knows naturally what to do.
This is Lane. Yep. We could use you a minute. Okay.
Go ahead.
I had read just recently the new article that they released from JDRF stating that, they're turning their focus away from the quote-unquote cure more towards the artificial pancreas at this time. Is that going to affect the research that they're doing that you just spoke about, with the, my brain is just forgetting what word, with the cells and
well, I wouldn't.
generating the base cells?
I don't think I would characterize it that way. The commitment has been and will continue to be that 2/3 of the money goes toward research toward the cure, and 1/3 is about glucose control and complications. What's happening with the artificial pancreas project is, 3 years and we'll have something. I mean, that's the plan. So it's something that's actually within reach. So whereas I could see, where JDRF is devoting resources to developing it because you can see where you're going to have a deliverable in a couple years. That doesn't take away from the ultimate goal, which is to cure type 1 diabetes. Next question.
What happened to the pancreas transplant? Is that anything that ever worked?
Yes, it does. In fact, my parents live in Fort Wayne. And when we go down to Fort Wayne to visit them, we always stay at the same hotel, and the person behind the desk had a pancreas transplant. He was a type 1 diabetic. And so just this past year, he had a pancreas transplant. We always ask him how things are going and stuff, and it seems to
work. Right?
Yeah, I mean, what you have to do, of course, is then you have to take medication to reduce the attack again, your immune system, so your body doesn't start going after the new one.
Destroy that one too?
Yeah, that's right. Yeah, yeah, that's the problem there.
I think generally they don't do the pancreas transplant unless you're at a point of needing a kidney transplant as well. And then because you're going to have to be on the anti-rejection meds anyway, it's worth it, to do it for the pancreas too. But at this point in time, I think the long-term complications of being on the anti-rejection meds versus just taking insulin without your pancreas working, it's really a better option to just take the insulin. But if you're going to have a kidney transplant, then they would consider doing a pancreas transplant as well.
Yeah, I don't know if this gentleman had anything else transplanted. What he said was, I've taken such bad care of myself over the years that this is what my doctor says we have to do now. So, sorry? Oh, we have another. Someone else has been paged. We heard the battle earlier, and these are the casualties? Okay.
Will the artificial pancreas, if you go low, give you glucose or whatever? A glucagon shot?
I believe, I think that's like stage 4, 5, or 6. Yes, that's also in there because.
I know they'll correct it up here,
right.
But down here,
right.
You keep going down.
Well, yeah, I mean, to turn off your insulin doesn't necessarily stop you from going down. So you're right. You need to have something, some sort of glucose system. Right. So that would be something where you'd have another vial in the system, but it wouldn't have to be very big because that hopefully wouldn't happen very often.
Yeah.
Yeah. Okay. That's a good point. Other questions or comments?
How do you become someone that tries it? Once it gets to, because they feel like they're trying it on actual.
For which?
Either one. Yeah. How would you go about it?
Okay, so I know for the anti-CD3 medication that there's been this public call for volunteers for trials. So is that usually what they do?
There's a link on the JDRF website actually for clinical trials. You can tell them what type of trials you're interested in, where you live, what type of travel you would be willing to do to participate in the trial, and they'll let you know what's going on in your area.
Yeah. So that's
the best way to find out when something is coming up, to have your name in the hat as to be able to participate in that.
That's JDRF.org. So, yeah. Other questions? I feel like I'm teaching my trigonometry class today. Yes, sir.
Well, this is probably the most advanced and best news that we've had in years, I would imagine. I mean, I'm rather new to the whole thing,
Okay.
but how long has it taken to get this to where it's at?
Well, there's many ways to answer that question. I mean, you can go back and say JDRF has been in existence for over 50 years now. 40, that's what I was saying. Grand Valley has been in existence for 50 years. So they've been supporting research in type 1 diabetes for 40 years. And some of the things that, for instance, the anti-CD3, so back in 1992 is when that was first identified as something that might have something to do with type 1 diabetes. And so now that's been almost 20 years now that they've gotten to the point where they actually have some sort of medicine that they're trying out. So these are the things that it takes a long time to do, and then you don't know if it's going to succeed or not. And you never know also where other ideas are going to come in. So something else that another research has been working on is just looking at the human genome, which has only been the last 10 years that the genome has been just determined what all the letters are, and they've been spending this previous decade to figure out, well, what letters do what. So I was just reading actually yesterday, so in terms of the T1 cells, they think they've identified an area on one of the chromosomes that affects how those cells are created and how those cells behave. And they think for people who have type 1 diabetes or susceptible, that little chunk of code's a little different than it is for someone who isn't type 1 diabetic. Now, if they can nail that down, then they can say that's the genetic piece of type 1 diabetes. But you couldn't do that 10 years ago because you didn't have the human genome. And the human genome the project wasn't set out. They didn't set out to do the Human Genome Project to cure type 1 diabetes. It was to get all this information that can affect all sorts of different diseases. So hopefully, within the next 3 to 5 years, they'll say that definitely is the piece, and that could develop at least a test to say, are you susceptible based on that piece? But all these things take time, and I know I'm relatively new to JDRF also because I was 2007, my son was diagnosed. But I understand that 10, 20 years ago, they were a little more, oh yeah, we're going to have this cured next week, kind of. And now we're like, okay, we know this is going to take time. We have to be patient, but there's all these different trials, all these different areas that people are working on simultaneously, and there's going to be a convergence where all this is going to come together, and that will lead either to a cure or to much better ways to control the disease.
One of the studies that's going on right now in Colorado is called the TEDDY study. My grandson is in that. My daughter lives in Colorado, and when she delivered him, they just said, we take some cord blood and send this off to the University of Colorado for this diabetes study that's going on. And she was like, well, sure. Well, come to find out, 2 weeks after he was born, they got a big package from this study saying that he had been identified as having a genetic marker for type 1. So they know that he's got this genetic marker, but not everybody that has it develops it. And so this study is looking at what are the environmental determinants of that. So is it, does it have something to do with, where you live or what you eat or, what are some of those things? And so he's now almost 3. Unfortunately, he doesn't have type 1, and I'm hoping he doesn't get it. But they're very closely monitoring him with blood samples, and they send in stool samples and food logs and diaries, and he will be in this for life. And then they'll take his data and compare it to somebody else and who gets it, who does it, and what are the common denominators. So, we might be 20 years, 25 years from now before we really have some concrete answers and all of that ongoing research to figure some of that stuff out. So it is a long haul. We never know exactly what diamond we're going to find in the process.
Right. Right.
And one of the things that has been interesting that JDRF is just starting to address is that a cure is different to different people. What I think is a cure is that this disease has gone away, nobody else can get it, and my kids won't have to take insulin anymore. For some people, smart insulin is a cure. For a lot of adults who have lived with this for 20 or 30 years, they say, if I can take a shot once a day or once a week, I'm cured. I don't need to think about this anymore. And they're happy with that. So it's the different pieces that resonate with different individuals as to what it really means. What piece are you going to be satisfied with as a cure?
Other questions or comments? Yeah, go ahead.
Are we able to create beta cells, make beta cells?
In certain situations, yes. I mean, but it's not even close to, something that you can go to your doctor and do. But that is part of it. Actually involves stem cell research, and there's I just read about this. I think we need to. There's a study where they were looking for volunteers to be, if there's a way to convert alpha cells to beta cells. So if you saw on the one side, the alpha cells create the glucagon in the pancreas. And the alpha cells and beta cells are very similar to each other. And is there a way to somehow coax some of the alpha cells to turn into beta cells? And I like that idea because there's a certain simplicity to it that, these cells they're all next to each other, and you just kind of tell the one cell, okay, start acting like a beta cell now. And if something like that, they can actually do that, I'd be very happy.
They've also discovered that cells will regenerate. Beta cells will regenerate. They will, in a healthy person, beta cell mass will expand during pregnancy, for example, or periods of rapid growth.
Right.
And so they're studying why that happens with individuals, and potentially shutting off the autoimmune response will allow you to take something else to help your beta cell mass increase, and that can work together as well.
I want to be clear. I think I've said before. It's not going to be January 1st, 2012 that we're going to have a cure for type 1 diabetes. But there's a lot of different areas of research going on right now that are, the hope is that will all converge in the next several years to come up with ultimately useful medicines, treatments, and equipment to make a difference for anyone who has type 1 diabetes.
When it's you and it's your kid that you're waiting for something to make it easier, it seems like it's taking forever.
Yeah.
But if you look back to where we were even just 10, 15 years ago in how we manage diabetes, we're so much farther ahead. Our pumps are so much smarter. We have continuous glucose monitors now. Even for people doing multiple daily injections, we've got better options in insulin that we didn't have 15 years ago. So there's a lot that has changed really in the fairly recent future. And you see how rapidly technology is changing. And I think your kids in their lifetime are going to be addressing and managing their diabetes probably in a whole different way than they're doing it today. They're going to see lots of changes come that help them to prevent complications longer and healthier.
And I can speak as a mathematician, because of technology, there's more data being collected. Lots more data. We're getting these large data sets. We have data sets, for instance, just continuous glucose monitor data sets. And there's a lot of research in mathematics and statistics right now about how do we analyze large data sets to get something out of it, get some good information. And this is the type of thing that, with this faster computers, and it's just a focus of a number of people in mathematics and statistics, that we may end up with, and this is something I work on as a mathematician, is you have all this data from continuous glucose monitors. So let's say you have 10,000 patients and you have this data. And then from mathematics and statistics, you've got these methods to look at large data sets. And there's something we can learn just from all this continuous glucose monitor data. maybe, for instance, we can identify certain groups of diabetics that have certain properties. And maybe there's something we can learn from that group and say, well, you know, this subset of this 10,000 sets of data seems to have something in common. And let's see if we can figure out what that is. Yes?
I guess the question I have, and it kind of dovetails into the comment that you had made about, you know, 10 years from now, we're going to treat diabetes much different than we do today. And I remember my daughter was diagnosed in 2007, and one of the things that was casually mentioned was the particular Lantus formula that Faith was using was a newer form of a long-acting insulin.
Mm-hmm. Right.
Who is going to be, or does JDRF see a role for itself in the education and the continuous updating of the current families that have type 1 children? It seems like if there would be the greatest need, I guess, is we know that the freshly diagnosed kids are going to have the most up-to-date information. But who is going to disseminate that information to the families who have, let's just say, gotten comfortable? We're 5 years in, we're 10 years into the treatment of our kids. Does JDRF see a role for itself in that? Is there an organization that does those sort of things?
Well, definitely. I mean, I think that's this position I have, this research information volunteer. This is a new position. I think it's established last year. And each chapter is supposed to have a research information volunteer. And it's in some ways it's up to the chapters to figure out what is our outreach going to be. So I would think for this chapter here in West Michigan is to reach out to everyone who has type 1 diabetes, every family that's involved, and convey information. So in trying to find different ways to do it. Like this is an excellent venue for this. We have with the walk, the fundraiser, there's different get-togethers to talk about that, and that can be an opportunity to talk about current research for type 1 diabetes. Is that what you're getting at, or?
So much mean in here's what's coming down the pipe. Because what the presentation you've made, I thought was awesome.
Thank you.
I had no idea at what stage some of these things were in. But I mean more of, okay, our daughter's had diabetes for 4 years now, and I talked to Caitlin. Caitlin
Yeah.
So there's, and I'm seeing, well, I wonder if there's a lag there. Once Caitlin got to the point where she could manage her diabetes very well.
Right.
How does a Caitlin, or where my daughter's going to be in 5 years, how do we keep up on what's actually working, not so much what's coming down the pipe? When new insulins are developed, who do you foresee as being the provider of that information to the families, or the source for that? Or is that something kind of new? Is that going to have to be grassroots?
Well, I think a lot of it has to come from the medical professionals. Because, exactly.
They switched me from NPH to Lantus.
Right.
You guys may not even know NPH was around.
Oh, it was a nightmare.
But it was horrible. I was miserable on it. But now that I'm on Lantus, I'm fine. So I was like about a year into having it. So, and he just kind of like changed things as we've gone. So I just rely on him.
But there is, to your point, I can remember going to, as a mom, going to the doctor with my boys, and somebody saying, well, what's your target? Their blood sugar target had been where it had been for the last 5 years. And they said, well, no, that's supposed to change as they get older. Well, you never shared that with me. So thanks for that update. And what should it be now, and what should we need to do differently? So part of it needs to come from the medical professionals, but another piece of that is really just getting together and talking to other people and using each other as resources is a tremendous piece of that.
Yeah, I think this is anything that involves you and your doctor, is that, my opinion is you can't count on your doctor to know everything. and you have to do some research yourself, and the internet is helpful, right? That wasn't here 20 years ago to be able to have this library at your fingertips. But ultimately, you want your doctor to keep up to date on these things also. One thing that kind of is difficult is, in terms of communication, is because of privacy laws, we can't go to a doctor and say, hey, could you tell us who has type 1 diabetes so we can send them some information? It doesn't work that way. And some doctors are actually, they don't want JDRF or ADA or anybody in their office, and they want to deal with their patients all by themselves. But I think ultimately the more we can have interaction between families that are dealing with type 1 diabetes and doctors, and have everyone talking to each other, the more information gets distributed around, and that's just better for everybody.
And don't forget your diabetes education team. If you're keeping touch with them, they're pretty good at knowing what's out there.
Yeah.
So it might be something simple, like there might be a different infusion set available that you could try. And just because you tried one pump and that didn't work for you, well, maybe there's another pump that would work better for you. So those kind of things, staying in touch with that team, and coming with your questions. Because usually when you make an appointment with a diabetes educator, you're looking at 30 to 60 minutes of time, as opposed to a physician who's maybe going to give you 15, 20. And so you can come with some more in-depth questions about what some of the needs are, and then hopefully they can help you consider what some of the options are to take back to a physician and discuss.
Yes.
So this question is not for you, really. What can we do here in this area to get JDRF more active down here? I mean, I get all these emails. Fundraiser up here, and this fun night, this and that. Well, it's on a Tuesday at 5:30.
Right, in Grand Rapids.
In Grand Rapids. And I would love to do this stuff and love to participate and give my fundraising dollars to that, but if I'm going to have to drive to Grand Rapids, on a Tuesday evening, they've had all these, people coming in and talking about the stuff that I've seen these emails for. Is there any way we can get them down here? Because I need this information too, but I can't make the drive to Kalamazoo or Grand Rapids once a week or once a month.
Right.
And I'd love to have, even here in this hospital, once a month we get those meetings or whatever, get those, because there's so much information you guys are giving up there, but we're not getting it down here where we need it to.
Okay, I see two different things to address there. Number one, if you want somebody to come down here, like Ed or myself, or to work with you, I know you have a really strong support group here, to help you get speakers or get what the information you need here, I'm all over that. I would get anything you can help with that. The second piece that I heard you say was the fundraising piece of it. Many of those are things that we're not doing, the staff isn't doing, but individuals within our community are doing. So if they go to their local restaurant, for example, our ride team is really good about this. They'll go to the Bubbly Bar, which makes awesome burritos, and they'll say, if we give people these coupons when they're coming in, will you give us 20% a year of the total? And so that's all organized by individuals, but we put it out to our email system, and we would be happy to do that for you as well. Send us anything that you have, and we'll put it out there for you. We'll put links to it on the website, things like that. So definitely.
Because, I'm seeing all these emails and I'm going, I'd love to go up there and do some of this stuff and do some of these, the guest speakers or whatever. And it's not feasible. People don't.
Is there much going on in South Bend? Since that's a closer drive for us.
Yeah, I don't know, but I could certainly reach out to our folks and stuff like that and see what's going on. I'm a lot of
They try to do like a slam but
Yeah.
they do a bunch of stuff down there. So maybe it's Northern Indiana group, and they do a lot of stuff.
Right. And there will be, coming to your area, kind of close, there will be a walking fundraiser this fall. I don't know a lot of details on it yet. They're hiring someone to set that up and run that. There should be a walk there this fall.
And our Living with Diabetes Families group we've done the walk for 2 years. I don't know how many people have been an email from me, but I send out an email every month. We meet the second Tuesday of the month. The kids get together and hang out and get to know each other better. Sometimes we plan activities, but we've done the walk for 2 years. We plan to do it again this year. So there's already a team in place with a Team 1 Eliminators. So it's easy to join, so you don't have the daunting task of doing that. You just have to show up at a meeting or email me or call me or whatever. Well, I live in Paloma, but we meet in St. Joe the second Tuesday of the month. So if you want to see me, yeah. So, I mean, we do have that in place. And, a lot of times I'll put in an email, if there's stuff you want to hear about or you'd like a speaker on, let me know and we'll line it up. We did have a nurse from Lakeland come and talk to our kids a couple months ago, and I was actually going to touch on that based on what you were talking about, the cure or the treatments coming down the road, because what I heard was, as a parent, what we need to focus on is helping our kids have the tools they need to care for their diabetes in the best possible way so that they're in a perfect position when these things come up to take full benefit from it 10 to 15 years from now. And one of the things that we gleaned from the session with the nurse when she sat down and talked with our kids without the moms and dads around, because they wanted that, was that sometimes we're really hard on our kids because we're like, you didn't change your needle, you didn't throw your strips away, you didn't do this, and you didn't do that, and you didn't, because we're always worried about that stuff and we're nitpicking. And we didn't think about it like that at all. And when the nurse sat with the parents and let the kids go, they were looking for, did you notice that I did check my sugar before my lunch every day this week? Have you looked at my meter? I didn't hear you say thank you and good job on that. Did you notice that I did change my needle? And as a parent, no, I noticed all the things you didn't do. I didn't notice a few of the things that you're totally getting right. And hello, you're only 8 or you're only 10. And grandma who has type 2 doesn't do these things. So, you know what I'm saying? So it was really beneficial for us as parents that night when we sat down, because the kids did take a chance to go, well, here's what we think. And so when you're talking about 10 years down the road, what I'm hearing is if we can really support our kids and give them the tools they need to take the best care of their condition, they'll be in optimal shape when those things are ready to step in for them.
Right. Yeah, and the favorite phrase in my house is, did you cover that? So I see by the clock it's 2 o'clock, so we'll have to wrap things up.
If these people are holding you in.
No, not at all. But
I know that you go on forever, but I don't want to keep you beyond.
I have a basketball game to listen to. So thank you very much.
Thank you.